Okay, in this video we'll look at some products and quotients of two values in polar form. So we have z1 and z2, and I wrote the formulas on the right, but let's break it down really quick. It's really quite easy. So when you multiply, what you do is you multiply the r's together and you add the angles. Because you add the same two angles, right? Theta 1, theta 2, theta 1, and theta 2 for cosine and sine. You really just need to do it once and either write in the second form or the first form. Either way. Now, it's pretty straightforward. I'm not going to prove why these are true in this video, just how to use the formulas, but it's pretty straightforward that if we multiply the r's. Then if we divide by the r's. And it makes sense that if we add the angles when multiplying, we would subtract while dividing. Right? So let's go ahead and do these two examples. I didn't write directions for the second because we're going to do the same thing. We're going to multiply both of these and then divide both of them. Alright, so the first example, z1 multiplied by z2 is equivalent to taking the two r's, root 2 multiplied by 2 root 2, bracket, only because we have multiple parentheses, cosine, theta 1 is 205 plus theta 2 is 118, and then sine will get the same exact thing. Okay, I wanted to do the first one really writing out the formula, and then square root of 2 times 2 square root of 2, so that becomes 2 times 2, which is 4, and then we get cosine 205 plus 118 is 333 plus I sine 333. I'm sorry, 323. Yes, plus I sine 323 degrees. Notice we don't have radians, right? Like, if it's given in degrees and it's ugly and you can't evaluate it and they want it in polar form, we often just leave it. And then just recall that you could write this as 4 CIS 323. Okay, so there's how to multiply. Division is very similar. Okay, we are going to take R1, so R1, right, and R2, theta 1, theta 2, and divide R2, oops, and then we subtract the angles, 205 minus 118 plus I sine 205 minus 118, okay, which should be 87. And then root 2 divided by 2 root 2, well, the root 2's cancel, so we just get 1/2. Okay, or 1/2 CIS, 87 degrees. And again, that answer is fine, leaving it like that. We don't really want to waste the time converting 87 degrees to radians. All right. Now notice when we did this, like I wrote this and then I wrote it again, right? You could just off to the side do scratch paper and add your angles, and then we don't need to write it, like it's kind of repetitive, right? So I'm going to do that for this one. R1 and R2, so, all right. I'm going to multiply. Okay, R1 and R2, I could multiply 6 times 2 in my head, right? That's 12. So R1 times R2. And then to add the angles, pi over 3 plus pi over 4, I need LCDs, so it'd be 12, so multiplied by 4 over 4 is 4 pi over 12, multiplied by 3 over 3, 3 pi over 12. So we get 7 pi over 12. Right, so 12, parenthesis, cosine 7 pi over 12 plus I sine 7 pi over 12. Okay, or again, 12 CIS, 7 pi over 12. All right, usually they want their answers to stay in polar form. If you did this and you got an angle in which you could evaluate, because that will happen, oftentimes you'll get, off to the side, you'll do your math and you'll get something that is actually on the unit circle that has an exact answer, I should say, on the unit circle. We still typically leave it. Usually they just want the result in polar form. Okay, if it asks for you to evaluate it all the way, then just, do the cosine of whatever the angle is, sine whatever the angle is, and distribute that 12 through. All right. For division, ooh, that line's getting thick, and I don't know why. Let me try to rewrite that. That was weird. Okay. So division, I could do 6 divided by 2 in my head, right? Or 1 divided by R2 is 3. Now the subtraction, though, if I look at my work from multiplying, I had to add. So the LCDs are going to be the same, so the only difference here is I have to subtract, right? And 4 pi minus 3 pi is 1 pi. So when I subtract, I get pi over 12. So 3, and we could even, if you like this form better, we could skip all the way to there, right? 3 CIS, pi over 12, and we're done.